Hi and welcome, I'm Gavin Lon. I'm a full-stack developer with over 20 years of experience. My main language is C#. There are many free courses available on this channel that can help you learn C# within various contexts, like for example Blazor or MVC. I recommend my Advanced C# course for those who already have experience writing code using C#. If you're totally new to C#, I recommend my C# for Beginners course. Links to these courses are available in the description of this video. So in this course, we are going to use C# in the context of writing a game using Unity. In this part of the course, we are going to write a C# script that will capture key presses from the user and control the player object in response to user actions. If you like this video, please hit the like button and please consider subscribing to the channel. Please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description of this video. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. So in effect, the script that we will create allows the user to drive the player object. In the first part of this course, I demonstrated the prototype on which we are basing the game that we are creating in this course. In the previous part of this course, the second part of this course, we installed Unity Hub and the latest version of the Unity editor. We created two game objects, one to represent our player object and the other to represent the ground plane. We discussed how to add physics like gravity to game objects, which was done by adding what's known as a RigidBody to our player game object. We discussed that when two game objects collide within the scene, that they don't simply pass through one another. The reason for this is that when game objects are added to our scene by default, they have what's known as a collider component attached to them. For example, the sphere has a sphere collider component attached to it. As you may have guessed, it has a sphere collider because of its shape, and the sphere collider, as it were, wraps the relevant game object. The cube game object that we added to represent the ground plane has a differently shaped collider. It has what's known as a box collider component. Of course, it makes more sense for a cube-shaped object to have a collider shaped like a box rather than a sphere, in the context of our game, at least. We discussed the hierarchy window in the previous part of this course, and as discussed, we added two three-dimensional game objects. We created a sphere, which is our player, and we created a cube, which is our ground plane. So let's start this part of the course by appropriately naming these game objects. Great. Let's add a C# script component to our player game object so that we can write code for a user to control the player game object, i.e. to move the player object appropriately through three-dimensional space. We can add our script file to a game object in various ways through the Unity editor. Let's start by adding a folder in the project window within the assets parent folder, and let's name this folder scripts. We are of course creating this folder to facilitate better organization of our project files. Then within the scripts folder, let's right-click the relevant window and select C# script from the relevant context menu option. Let's name our script PlayerMovement. So to add our C# script to our player game object, we must ensure that our player game object is selected in the hierarchy. Then we can drag and drop the script from the project window onto the inspector window like this. Of course, this must be done while the player game object is selected within the hierarchy window. Great! As you can see, we have added our script to the sphere game object. You don't need to follow the next few steps regarding other ways to add script components and deleting existing script components. I'll demonstrate this just for extra information. You can delete a component from a game object like this. You can add many script components to a game object through the inspector window, like this. So I'm going to delete these two script components from the player object. We only want the script that we named PlayerMovement attached to the player game object. You can also add an existing script to a game object like this. By default, when you add a script through the inspector, the relevant script file is added to the assets folder. So if you have added script components through the inspector that you no longer need, you can delete the relevant scripts from the assets folder here. And let's ensure that our player movement script is added to our player game object. Great! So in this course, we are going to use Visual Studio Code as our script editor. So if you don't have VS Code installed, you are able to navigate to this URL and install VS Code for free. Once VS Code has been installed, we can set up VS Code within the Unity editor as our preferred scripting editor. So to do this, let's go to Edit, Preferences. Let's select the External Tools option in the left pane of the Preferences dialog. From the Script Editor drop-down, we can then select our preferred script editor. I have Visual Studio 2022 installed, so I could choose this option as my preferred code editor. But let's choose VS Code as our preferred code editor. We can now load our script within VS Code by simply double-clicking on the relevant script, either from within the inspector window or the project window. You can navigate to this webpage in the Unity docs for details about VS Code being set up appropriately for editing C# scripts in Unity. It should be very straightforward, so you should be pretty much good to go once you have double-clicked the relevant script file within the Unity editor and consequently launched VS Code with the relevant script file loaded. If you have any issues regarding setting up VS Code for Unity, please read the documentation at this webpage. Let's look at the default code within our PlayerMovement script file. You can see the class has been named PlayerMovement, the name that we gave to our script file when we created it from within the Unity editor. Within the Unity editor namespace is a base class named MonoBehaviour. Our PlayerMovement class inherits from Unity's MonoBehaviour class. This allows us to provide custom code in response to certain Unity events. You can see here we have the start method and the update method provided by default within the PlayerMovement class. We can provide custom code for these methods, and when certain Unity events fire, our code within these methods will be executed. Inheriting from Unity's MonoBehaviour class makes this possible. If you'd like to learn more about C# inheritance, I've included a link to a video series on inheritance in C# provided by this channel. So, as you can see in these two comments provided by default within our script, the start method fires before the first frame update. The update method is called once per frame. So in terms of how the visuals of the game are presented to a viewer, the game is pretty much like a movie, where really what is happening is a number of still images are being shown really quickly in a particular order within a view screen, one after the other, creating the illusion of movement in three-dimensional space, which is why the movie watcher or game player in this case has the experience of progressing through the game. So 30 frames a second means 30 images are being displayed one after the other in a particular order within 1 second of time. So before the first frame is even started, the code within the start method will execute. The code, however, within the update method will execute once per frame. So in the start method, we are simply going to write code to reference the RigidBody component that we added to our player component in the previous part of this course. We can do this by firstly defining a variable. Let's make this a private variable that is defined as the RigidBody type. Let's name our variable RB. Then before the first frame runs, as it were, we want our code to make a reference to the RigidBody component that is attached to the player GameObject. So we can do this by adding this code within the start method. So if you are familiar with C#, you may be familiar with a concept in C# known as generics. This code uses generics to find the RigidBody type attached to the player GameObject, so that we can have a reference to the appropriate object that is derived from the RigidBody type. I've included a link to my video series on generics below in the description of this video for those interested in learning more about C# generics. As discussed in the previous part of this course, the RigidBody component allows us to apply physics to a game object, for example gravity. But we are going to write code in the update method to apply a forward force to the player GameObject in response to the user pressing down the W key on the user's keyboard. Note that it is recommended by Unity to write any physics-based code, for example applying forces to game objects, like the code we are about to write, within a method named fixedUpdate. We'll discuss the fixedUpdate method in another part of this course. Using the update method instead will be fine for our purposes in this part of the course. So to do this, we can first write an if statement so that Unity, as it were, can detect a user pressing down the W key. So if the user is pressing down the W key, we want code to execute that applies a force to the RigidBody component using the add force method, like this. So the add force method is called on the relevant RigidBody component. If you are interested in learning more about C# if statements, I've included a link to a video tutorial on C# if statements below in the description of this video. So you can see here that the add force method accepts 3 arguments: a number representing how much force should be added on the x-axis, a number representing how much force should be added on the y-axis, and a number representing how much force should be added on the z-axis. If you look at the sphere object within our scene view in Unity, make sure the cross arrows icon is selected here. You can see Unity expressing the x-axis, the y-axis, and the z-axis pertaining to the sphere or player GameObject. The red arrow represents the x-axis, the green arrow represents the y-axis, and the blue arrow represents the z-axis. What do all these values passed into the add force method represent? They represent a 3-dimensional vector. So, in the context of the 3D space in which our game is played, a vector comprises of 3 numbers. These 3 numbers represent a single value that expresses direction and magnitude. We'll discuss vectors in more detail at a later point in this course, but at this stage, understand that vectors are fundamental to writing games. In a 3D game like the one that we are writing, 3D vectors are used, where 3D numbers x, y, and z are used to represent direction and magnitude in 3-dimensional space. And of course, in a 2-dimensional game, 2 values, x and y, are expressed to represent direction and magnitude within 2-dimensional space. So we want, in this case, to only apply a forward force, which means we are applying a force on the z-axis, so the player will move into the distance. The player will move away from the camera and towards the far edge of the ground plane, toward the horizon. No forces will be applied on the x-axis or on the y-axis of the player GameObject through this line of code. So this line of code will move the player object in a straight line towards the horizon on the z-axis. Before we run the game, let's briefly discuss what the Time.DeltaTime value is and why we are multiplying the force applied on the z-axis of the GameObject by Time.DeltaTime. If we navigate to an appropriate web page, so this URL, in the Unity docs, we are presented with details regarding Time.DeltaTime. So Time.DeltaTime is simply the interval in seconds from the last frame to the current one. The reason we are using the Time.DeltaTime value like this in our code is so that regardless of the frames per second, FPS, at which the game is running, so one user might be running the game at 30 frames per second and another user might be running the game at 60 frames per second. The game will be executed at the same speed for both players. So both players will experience the game at the same speed. So Time.DeltaTime helps us to make our game frame independent. One more thing to note is the F suffix here, used at the end of the literal value of 500, passed into the third parameter of the addForce method. In C#, this simply denotes the type of a literal value. When I say literal value, I mean the value itself is expressed in code, in this case 500, and the value in code is not represented by a variable, i.e., where the variable stores a particular value. For example, the value of 500 could be stored in a variable named forward force. That is defined as the float data type. C# is a strongly typed language, which has many advantages over dynamically typed languages, like for example JavaScript. One advantage is data type related errors can be caught, as it were, at compile time, potentially making the game at runtime more robust. For details on C# data types, I've included a link to a C# tutorial on C# data types below in the description of this video. Right, let's run our game. And we can see that we are able to apply a forward force to our GameObject by holding down the W key. Excellent! We can add code that adds a force to the Z-axis, but in the opposite direction to when the user presses the W key. So let's add code so that when the user presses the Z key, the player object moves in reverse. The line of code is almost the same as the line of code used to apply forward force to the game object on the Z-axis. But in order to move the player object backwards, we simply add a minus sign to the relevant value passed into the third parameter. Excellent! Then we can write code so that the user can control sideways movement of the player game object, like this. So to move the player object to the right, we can add this code, so that when the user holds down the D key, a force is added to the left side of the player game object. And the game object moves to the right on the ground plane. Note that in this case, no force is being added to the y-axis or the z-axis of the player object, but only on the x-axis of the game object. So to move the player to the left, the opposite direction, we can write this code. So when the user holds down the A key, a force will be added to the right side of the player object, and the player game object will move to the left. Excellent! We are going to want to try out various force values during the development of our game. So it would be great if we can somehow change these values from within the Unity editor. So we are able to do this simply by creating the appropriate variables with public access modifiers within our script. So let's define a public variable named forward force as float. And let's also define a variable named side force as float. Now when we go to our Unity editor, we can see that we have two relevant text box fields available for us to enter the relevant values within the inspector window, where our script component resides. So let's play around with these force values.
Wow!
What?
Excellent! In the next video, we'll write a C# script so that the camera follows the player game object dynamically. I hope you've enjoyed this part of the course. If you liked this video, please hit the like button and please consider subscribing to the channel. Please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you're feeling generous and you feel like thanking me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. I look forward to seeing you in the next video. Thank you and take care.